Okay, so as we go into lesson 1-3, I said have your calculators out, right? It says 12 basic functions. These are 12 basic functions that we see a lot in math. Some of these you already know. We've used them a lot in prior years. Some of them are going to be new to you. But they are all common graphs that we see in math that as you're in pre-cal, it's a little more upper level. For those of you who continue to calculus, upper level. The more upper level maths you're in, the better it is to know, like in pre-calc, I should easily be able to say y equals x squared, and immediately you have that picture in your mind. No doubt about it. And that's what, as you think about these are ones that you need to have a picture in your mind. You need to know the basics. So do you need to memorize them? Somewhat to an extent, yes. I mean, at least familiar with them. The more we use them, the more they'll be memorized. Okay? So, we're going to go through. We're going to talk about what these graphs are. Some of them I'm hoping you already know before you even graph them on your calculator. And we're going to talk about domain and range of them. So kind of the features of the graph. So, y equals x.
Straight through.
Yeah. And if you prefer, you can think about y equals x plus 0, right? So it has a intercept of 0, and it goes, as a slope of 1, goes straight through the origin. Now, the general idea here is, if it's just y equals x, it's going to be a line, right? So this is called the identity function. One thing you need to be familiar with the equations and the names, because that's one of the things, I think I have that, either have that on the quiz or the test. Can't remember. Maybe I don't do that for the test, but, okay, so identity function. Basically, it's a line. The equation represents it, y equals x. What's my domain? How far left and how far right does a line go? Negative infinity to positive infinity? Or in other words, all real numbers? Range. How low does my line go? How high does my line go? Okay, again, it's all real numbers. Negative infinity to positive infinity. Okay? Basics there, right? Okay, the next one. Can you do it without your calculator also? Y equals x squared. The squaring function is what they call it here. What is it?
Parabola.
Parabola. The traditional parabola is centered at 0, 0. Officially, it goes through 0, 0, 1, 1, 2, 4. We're not getting that specific here, okay? I'm just looking for the basic sketch. I did hear the word parabola, so I'm going to throw that in there because, it's good to make sure we know our vocabulary. Domain. How far left? How far right does a parabola go? Infinitely left and infinitely right. I just taught this in Algebra 2, so you guys would have seen this last year. But domain for a parabola is always all real numbers as well, because whether the parabola is opening up or down, it's getting infinitely wider. What about the range?
Just 0.
Okay, so how low does it go? This one, y equals x squared, starts at 0, 0, so 0. How high does it go? Infinity. Now, when we talk about 0 to infinity, I'll give you the easy one. Infinities always use parentheses. What about that 0? It's a bracket because the parabola goes through the point 0, 0, yes? Does that make sense? So that one's a bracket. Okay? Cubing function. The curvy one. This is one you should be somewhat familiar with. We graphed this in Algebra 2. Okay? It's the curvy one, he says. How about that curvy one?
Yeah.
Okay? It could be, stretched out much skinnier. It could be squished down more. Sometimes, if you add in extra terms to the y equals x cubed, sometimes it will go up, come back down a little bit, and go up. We've seen those in our graphs lately. Okay, so this is your cubing function, the cubic. Y equals x cubed. How far left and right does this graph go? Yeah. As it goes farther down, it's going farther left. As it goes farther up, it's going farther right. So domain, all real numbers, negative infinity, positive infinity. Range. How low does my graph go? How high does it go? Excuse me. Negative infinity to positive infinity.
My infinity sounds really good. One or two.
Now,
Well, I'm with
one thing I want to point out, piece of vocabulary, right here, and it happens to be at the origin here, is a point where my graph kind of changes how it's curving. And this is an inflection point, or I actually have it written in my notes as a point of inflection. And I don't know that we talk about that much in pre-calc, but calculus talks a lot about inflection points. In fact, I was just talking to them about concavity yesterday, which is, what's changing. My graph is changing from being curled down or curved down to curved up at that point. Okay? Okay, row 1 wasn't too bad, was it? Okay? Row 1 is the row you should already know, my opinion. Okay? Row 2. In all honesty, ironically enough, I've already graphed 2 of these today for you guys. And just talking about homework questions. Which goes to show, if you know a little bit about them, they are helpful. So, the reciprocal function.
That's where you have like the 2 and the 1 side.
Yeah, y equals 1 over x. Let's see here. I didn't erase it. Did I graph that?
Yeah.
Hey, we know the reciprocal function is odd then, correct? Because we just talked about it right there. So the reciprocal function, 1 over x. And this is one, feel free to graph it on your calculator if you want, any of these. But 1 over x, it is symmetric. Both of those pieces should be identical. I just can never draw them identical. Okay. It is also called a hyperbola. Which is something we'll talk about
An exaggeration.
in January or whatever when we do our conic sections. So we'll talk about hyperbolas there. I think it's January. And if you put a negative on this, then it means my graph is going to be in the other 2 quadrants. So, it can change, obviously. Okay, we have to start thinking a little harder here. Domain. How far left does this graph go? Infinitely left. How far right does it go? Infinitely right. Does it have any breaks in the middle? As I come from the left and I think about tracing this piece, all of a sudden it's going to turn and go down, isn't it? What x value are we not touching? 0. Because what is at 0? What is that break though? It's not a hole. It's an asymptote. Okay? If it's a hole, my graph pieces connect and there's just a little baby hole there. This is a bigger break. Okay? My graph is going 2 different directions. That's not a hole, that is a asymptote. So right there's an asymptote at 0, which, hello, keep putting stuff together. Does it make sense? There's an asymptote at 0, a vertical asymptote at 0. Denominator, x equals 0, yes? Okay. So my domain goes from negative infinity all the way up to 0. Am I going to touch 0?
No.
No, so I'm going to use a parenthesis. Union. Where do we start back up on the other side?
0.
Still 0, right? By putting parentheses, it just means we're not including 0. But we still use the number 0 with parentheses to infinity. And that's domain. Remember, domain is x values. We read left to right. Okay. Range. Difference on range, we're going to read bottom to top, right? Up and down. How low does my graph go? Negative infinity. How high does my graph go? Positive infinity. Do we have any breaks along the way? Yeah. As I graph up here, graphing. As I'm getting closer and closer to the x-axis, all of a sudden my graph takes off towards Mr. Stanley's room, doesn't it? Okay? And so, right there, am I ever going to touch 0?
Yeah.
No. Now, where does my graph pick back up? The other side of 0, right? Now, it also moves to the right, but that's fine. It's still 0 and then up to infinity. So I'm going to say negative infinity to 0, union, 0 to infinity. Does it make sense if we say there's a horizontal asymptote at y equals 0? Why?
Because it'll keep going, but it'll never cross it.
Okay. Yeah. What's the rule that tells me there's a horizontal asymptote at 0? The bigger power is on bottom. Can we still use that?
Wait, what thing is this?
No, because there's no x on top.
Oh.
There's no x on top, so there's no power on top, where x is 0. On bottom, there's power of x to 1. So the bigger power is on bottom. Bigger power on bottom says horizontal asymptote of y equals 0. Do you see how I'm pulling these 1, 2 things in here? It all connect. All that stuff we've spent the last week working on with lesson 1.2 are all features of the graph. Okay, so asymptotes, we're talking about those there. We'll come up with other things. Okay, you ready for square root function? Haven't drawn this one today. We've talked about it. We've talked about it points this year, though. Do we know what the square root function looks like?
This kind of goes out. Starts as positive. Starts at 0, 0.
Okay, starts at 0, 0 and goes out. They're trying kind of drawing a curve in the air here.
Is it like that? Yeah, it's the one that just goes like that.
How about half of a
It's
parabola?
like a half of a parabola.
Like that.
It is specifically half of a parabola. It's not even like half of a parabola. It is half of a parabola. Okay, again, that's another connection. Here's how I know it's half of a parabola. Because y equals x squared and y equals the square root of x are inverse functions. Okay, they're inverse functions. That means you take the graph and you change it from vertical to horizontal. Now, we only have half the parabola, though, because the square root cannot have a negative value. We'd have to put a plus or minus out there. So, now, that square root function, half a parabola. Thoughts on the domain?
0 to infinity.
Yeah. How far left do I go?
0.
We're going to start here at 0, and then we go to infinity. Infinity always uses parentheses. What about 0? Can we include 0?
Be a bracket.
Yeah. And here's ways to check. First of all, can you put 0 in this equation? Yeah, I can do the square root of 0. Square root of 0 is 0. As opposed to back here. Can I put 0 in this equation? I can't do 1 divided by 0. Okay? If you hit trace on your calculator, it probably puts you right at 0, 0, doesn't it? And if you move left, it's going to take you to a y value that doesn't exist. If you move right, you get values. Okay? What about range? How low am I going?
0.
Okay? 0. How high am I going? Positive infinity. Because, yes, it's more going off to the right, but as it's going to the right, it's going to keep getting bigger. What'd you put with your 0? A bracket. That's familiar, right? That's a familiar graph. We haven't used it as much. However, we graphed those in Algebra 2. We did, now that I think about it.
We learned it towards the end of the year, I think.
I don't remember when we learned it. I just know that because we did the transformations with them, where you're moving them left, right, up, down. So, which transformations I feel is more first semester.
Because didn't it have like the H and the K and stuff like that?
Yeah.
I hated it.
Okay. Exponential function is another good one to know.
I remember I covered it. We covered it last year.
Okay. Yeah. You know what? And that does remind me. I do teach exponential functions in Algebra 2.
We never really got too deep into it. She just said that Paris.
Yeah. And I'm trying to think how deep we got into it. I don't know. But I already graphed an exponential function today, except the exponential function I graphed was 1.5 raised to the power of x. So realize exponential function, that e, what is e? Do you remember?
Isn't it like 1 point?
No.
The E's for exponential.
No.
Oh. What is it?
So E
Sorry.
is called the natural number.
Yeah.
I'll teach you that.
When we did logs, I taught you E.
Yeah.
And it's like pi in that it is an irrational number. It's a number that goes on and on forever and ever. Okay? Now, with that in mind, E is like pi. E represents a number, value, that's an irrational number. Now, here's the deal. For the exponential function, so this is basically saying 2.7 raised to the power of x. An exponential function could be any number in the base. Earlier it was 1.5 to the x. It could be 10 to the x. It could be, that E is this specific number, but my point is an exponential function is just some number raised to an x. And I don't know if you guys have seen these any in like chemistry or biology at all, but
In chemistry, that should be.
I feel like
Two.
exponential functions should come up somewhere there.
Because it was like, I guess,
So.
backwards logs.
Exponential looks something like that.
That's what I got.
Okay. Now, the traditional exponential function, if it's not moved up or down or anything, will always cross through the y-axis at 1. Obviously, if, depending on what's done to the equation, it might be different. But the traditional one cuts through 1. How far left is this graph going?
Negative.
Negative infinity. How far right is it going?
Also,
As it's going up, guess what?
keeps going.
It's still going out wider. There's not going to be a vertical asymptote stopping it. So domain, negative infinity to positive infinity. Or think about it. What values can I put in for x? I can put anything in a power I want, can't I? Okay. Range. How low does this go?
Wouldn't it go negative infinity just like when it keeps going?
How low does it go?
It doesn't.
What is the x-axis acting as? An asymptote, yes? So this x-axis is a horizontal asymptote. And if that is a horizontal asymptote there, my graph is never going to go below it. What is the y value of that horizontal asymptote? 0.
Go with the parentheses.
Okay, good. It's going to be 0 with a parenthesis, because am I ever going to touch 0? No. How high does my graph go? Infinity. Okay. Got the basics here? Now, we just did the exponential function. The inverse of the exponential function is the natural log function. Okay? Again, my Algebra 2 peeps, we graphed this last year when we graphed exponential functions. So, log function was running along the x-axis and increasing, yes? Exponential function, have you looked at it? Runs along the y-axis. And are you graphing some of these along the way as we go?
Yeah.
I probably should be suggesting that a little bit more. If nothing else, to make sure we know where all the buttons are to push.
I just found the button.
Yeah. The LN button is a pretty obvious button. E for the last one, E is a second function of, is it ln or log or something? Is E above the ln? Yeah.
Oh, there it is.
So-
I am going.
LN button is just there on the left side.
Yeah.
It's very,
And then
well,
sin.
I won't say it's very obvious. It should be very
It's not
obvious.
very obvious.
Left side.
It's like the
Bottom-ish.
Yeah.
Why don't we graph tan?
Go Kylie's direction.
Oh.
Okay.
And I
Okay.
also saw an E over here says
You'll have
that E.
And you could use that E, I think, but the other E is designed for the exponent already, if I'm not mistaken.
What
is
ln?
Okay, so ln stands for natural log. Okay? If this said log x, like log, it would be a very similar graph. Okay, so ln is representation for natural log, and it is the inverse function. And so if you reflect across the y-axis, or excuse me, the diagonal line y equals x, it would be the same. Now, Kylie just commented yours don't look the same. Do yours not go all the way down? Okay. So the idea here is that that's graphing failure here. So have you guys graphed this one? You probably should if you haven't. If I graph natural log of x, it doesn't appear to go all the way down along the axis. However, that's where you need to know it does. That is just graphing calculator failure. The graphing calculator cannot always make it look exactly right. And this is one of those places that happens. And so this does run alongside the y-axis like what I have drawn up here. Okay. A traditional natural log of x is going to cross through the x-axis at guess what? 1. Okay. Domain. How far left does my graph go?
Never crossed.
It's never going to cross that y-axis, which is an asymptote of 0 to infinity. 0, since it was an asymptote, we're never going to cross it. We're going to use a parenthesis. Range. How low does this go?
Negative.
Yeah. My graph, and this is where you have to look at my graph, don't you? You have to know better. You have to be smarter than the calculator. This is going to go down to negative infinity. How high does my graph go? Positive infinity, yes? Okay. You guys all found the ln x button then, right?
Yep.
And then did you use e to the x? So if I do second and the ln button, we get e and I can put an x there, right? And thus, now you'll notice there, my ln x does give me the whole graph. Okay. So, do you guys know what sine x looks like?
Yeah, it looks so
It's
fun.
really fun.
It's like a little squiggle.
So we'll see.
There are hills.
So, okay, everybody graph sine x. Everybody. Not, oh, I'm an exception, I don't have to do it. No, everybody.
See, when I say graph, it looks like this. It just looks fun.
That's why everybody needs to graph it.
Mine's lines. You're gonna have so much fun colors. Mine doesn't.
And backgrounds.
Okay,
Mine looks like a squiggle.
we need to talk. Your calculator does not look like my calculator, which is why I want everybody graphing it.
Z standard window.
Now, stop and listen to me, please. Okay, first of all, yes, make sure you're on Zoom Standard. You guys always need to go back to Zoom Standard. So many of you, when I help to solve your problems, you're like, my graph doesn't look right. Did you start off on Z6?
Probably.
Now, doesn't look like mine yet. And that's the thing, some of you don't. So, here's what we have to learn, okay? And physics people, beware. Okay, beware. You're going to want to change your calculator back out of this mode here in a moment. Okay, but in trig, we talked about sine, cosine, tangent. These are trig functions, right? Trig functions work in radian mode,
Okay.
not degree mode. Okay, so if your calculator's already in degree mode, which physics people you would be, you have a problem, don't you? Okay, so now, in order to change your mode on these calculators, and this is, everyone, guys, we're all going to have to do this at some point, okay? Might not be till second semester, but my calculator says it's in radians, okay? Now, Noah's calculator isn't going to say it's in radians or degrees, but mine says radians right here. Sophie and Hannah both were giving me that look, so there's said degrees right there, I'm sure. If I use mode right here, which is in the, like, almost top row, and if I go the very towards the top, I have a choice of radian or degrees. most of this stuff we've graphed today, it doesn't matter. Except sine and cosine. You must be in radians or things won't look right or work right. So you can switch that over. Make sure you get to radians. So make sure radians is highlighted by clicking on it, and then go back to your graph and try again. And then you should be getting the curvy thing, right?
Yeah.
Now, I actually like Z-trig on this one, 'cause it's a trig graph. I'm going to use Z7. It shows it even better. Okay.
Could I do that instead of changing it to radian? Would I be able to do that?
No, you still have to be in radians. Okay. Did everyone get their graph looking right? This is important that you understand how to do this.
I got
Did you get?
I just hit Y to. I changed the zoom or the window.
Okay, maybe you weren't back on Zoom 6 then. I don't know.
I hit
Okay.
Zoom 6.
Did you get yours figured out? Okay, everyone's good then?
It's signing
Okay.
wiggle.
So, sine function is, again, it's one of our trig functions. You must be in radian mode. And Sophie and Hannah, are you my only two physics?
And
And Edna. Okay, so you guys know you have to change modes back before you walk into Mr. Kevin's class, right? Or it's going to be advisable. You want to be in degree mode for Mr. Kevin. Okay. And honestly, you walk out of my room today, you can go back. You know, we won't use it that much right now. So, okay, sine x. The idea of the sine function is a traditional sine function starts at 0, 0. It goes up and down, right? Goes up and down, and that goes on forever. It goes to a height of 1, and it goes as low as -1. This is, of course, with no stretch or compression. And we talk about a cycle going to 2 pi. So, like right here, what I just drew is a cycle that goes to the right 2 pi units and to the left 2 pi units. We will learn to graph these second semester by hand. For right now, I just want you to be familiar with the sine graph that goes up and down, up and down. Okay? Domain. How far left and right does this go?
Negative infinity, positive infinity.
It's going always, right? Negative infinity to positive infinity. Range. How low does this graph go?
Negative 1.
Always -1. How high does it go?
Positive.
Positive 1. Always, every time. What about -1 and 1? Parentheses or brackets?
Brackets.
These are, it's almost like parabolas in a way. They are going to touch those 1s and -1s. If you want to, you can go ahead and graph cosine on that same graph real quick. We'll talk about it on Monday. Remind me where I need to pick up. We'll talk about it on Monday, and then we'll go through some example questions of what you'll see in homework. Because homework is answering questions about these graphs.
This is homework.
The homework will not be due till Tuesday.
Okay.